All right, so you ever clicked a link and wondered how that web page magically appears?
Yeah, it is pretty amazing.
Today we're diving deep into that, the hidden language of the web.
Oh, cool.
It's called HTTP. It's how your browser, chats with servers to bring you all that online goodness.
Like magic.
We're using excerpts from the official HTTP Semantics spec,
Okay.
RFC 9110.
Got it.
This is like the rule book for how the web should work. We'll uncover some surprising details, stuff you probably never more, and more importantly, why any of this even matters to you as someone who uses the internet every day.
Well, it is fascinating. Like, we all use it every day, but don't really get it.
Right.
It's kind of like driving a car without knowing how the engine works.
Exactly.
Or like speaking a language without really understanding the grammar.
So, let's pop the hood on this engine, shall we?
Let's do it.
First off, what exactly is HTTP? Like, it's got to be more than just fetching web pages, right?
Oh, way more. It's really the foundation of the web, like this set of rules, right? It governs how computers, they talk to each other to deliver like everything.
Everything.
Web pages, videos, you name it.
Okay.
It's all about manipulating and transferring what we call representations of resources.
Representations of resources. Okay, that sounds a bit abstract.
Think of it this way. A representation, it's kind of like a snapshot of a resource at a particular moment.
Okay.
So, for example, the HTML of a web page,
Okay.
a JPEG image,
All right.
even the current weather in Laguna Beach. These are all representations of different resources.
Okay, so the actual image file on a server, that's the resource.
Right.
And the image I see in my browser is the representation.
Exactly.
Got it.
It's kind of like, when you order food off a menu,
Yeah.
the menu you see is like the representation.
Okay.
And the kitchen preparing your dish, that's the actual resource.
Makes sense.
So HTTP, what it does is it facilitates that entire process of ordering and serving information online.
Okay, so we're not still using the same HTTP from the 90s, right?
Oh, definitely not.
This language, it must evolve somehow.
It does. It evolves through versions.
Okay.
So we have major versions.
Okay.
These, they introduce, big changes. Sometimes they're not backwards compatible. It's kind of like switching from Latin to English,
Oh, okay.
And then we have minor versions.
Okay.
These, they add new features, but they keep things, backwards compatible. It's like adding slang to English.
So my old browser can understand a newer server, but it might not get to use all the fancy new features.
Exactly.
Got it.
Like, imagine trying to watch a 4K movie on an old black and white TV.
Okay.
You'll get the picture, but you won't get the full experience.
Makes sense. Now, you mentioned URIs earlier.
Right.
Those are addresses on the web, right?
Yeah, URIs, those are the things that start with HTTP, / or HTTPS.
Right.
They basically tell your browser where to find what it's looking for.
Okay, so they're not just static addresses though, right?
Well, that's the interesting part. They can actually be used to perform actions.
Wait, so clicking a link, it can do more than just take me to a new page.
Exactly.
Whoa.
A URI could be structured in a way that it actually triggers actions, like deleting a file.
Okay.
Or submitting some data. This is why, you should always be careful about clicking on links you don't recognize.
Right, especially if they have weird characters or something.
Especially if they have what we call query parameters, unusual ones.
Okay, so how does HTTP know the difference between a URI that's a location and a URI that's an action?
Right. That's a good question. HTTP tries to keep those meanings separate, but it really relies on the resource owner.
So the person who made the website or whatever.
The website developer to implement those actions safely.
So it's a shared responsibility, kind of.
Yeah.
The protocol's giving you the tools, but it's up to the developers to use them wisely.
Exactly.
Now let's talk about the characters involved in all of this.
Okay.
We have the user, we have the browser.
Uh-huh.
Who else is on the other side?
Right.
It's not just one big computer sending us everything.
No, it's a whole network of things. First, you have the origin server.
Okay.
This is the main source.
The source of truth.
Yeah, the website you're actually trying to get to.
Okay.
But between your browser and that origin server, you often encounter these things called proxies and gateways.
Like middlemen.
Like middlemen, yeah.
Why are they involved?
Well, some of them are helpful,
Okay.
like proxies that cache content to speed things up
Oh, okay.
or add security. But then there's some less desirable ones, like interception proxies. These could be intrusive. They can mess with HTTP in harmful ways.
Like those annoying pop-ups that demand payment on public Wi-Fi.
Exactly. Those are the worst. So proxies, they could be friend or foe.
Okay, so what about gateways? Those sound even more mysterious.
Gateways, they basically act as intermediaries.
Okay.
Often they pretend to be the origin server themselves.
Whoa, why would they do that?
It could be for performance reasons, like to optimize things,
Okay.
or security, but it can, lead to complications if it's not configured properly.
Sounds like we really need to be aware of like who we're actually talking to
Yeah,
online.
right.
But this whole conversation must be pretty complex.
Yeah, it is.
Like, how does my browser even know what to ask for and then how to understand what it gets back?
That's where these things called HTTP headers come in.
Okay.
You can think of them as like hidden instructions, tucked inside every request and response.
Like secret messages.
Like secret messages, exactly.
Oh, this is getting interesting.
So some headers, those are essential,
Okay.
Like content length.
All right.
That tells the browser how big the data is going to be.
So it knows when to stop waiting?
Right. Content type specifies the format of the data.
Like whether it's HTML or an image or something else entirely.
Exactly.
So it's like the server saying like, here's a package, this is how big it is, and this is what's inside.
Yeah, exactly.
Okay.
And then you have these other headers. They're more nuanced.
Okay.
Like last modified.
Oh, right.
That one helps caches figure out if they have like the latest version of a resource.
Oh, clever. So we don't have to download the same thing over and over again?
Exactly. It saves bandwidth and time.
That's smart.
So it's all these little whispers back and forth, making sure everything runs smoothly.
Exactly.
Now, have you ever gone to a website and it like automatically gives you the version in your language?
Yes. I always wondered how it does that.
That's something called content negotiation.
Okay.
Your browser, it uses headers like accept language to say what its preferences are, and the server tries to match those.
So my browser's kind of picky.
What it is,
It's not just like passively taking whatever the server sends it.
it's got standards.
It's got preferences.
Exactly.
Okay.
And these headers, they're crucial for providing a personalized web experience.
Yeah, that makes sense.
Now, how these preferences are actually like communicated and negotiated, we'll dive deeper into that in the next part of our deep dive.
This is already more complex than I imagined.
Yeah,
I can't wait to unpack more of these hidden mechanisms next time.
it's going to be good.
We left off talking about how my browser can be quite the diva with its preferences.
Oh yeah, picky browsers.
It's fascinating like how all these behind-the-scenes conversations actually shape our online experience.
Yeah, it's a whole lot going on under the hood.
But how are these preferences like actually communicated? How does my browser tell the server what it wants?
Well, that's where this thing called the queue parameter comes in. It lets your browser actually rank its preferences with, like, numbers.
Numbers. Okay.
So it might say, hey, I prefer English, Q equals 1.0, but I'm okay with French, Q equals 0.8.
So it's like a weighted preference system.
Exactly, yeah.
My browser's saying, I really love this, but I'll settle for that if I have to.
That's a good way to put it.
Okay.
And this whole system isn't just for languages, by the way.
Oh, really?
Yeah, you can have similar negotiations for, like, character sets,
Okay.
content encodings like zip,
Oh, right.
and even different media types like, HTML or plain text.
So it's all about finding the best fit between what the client wants and what the server can give them.
Exactly. Yeah, it's like matchmaking, but for web content.
For web content, I like that. But even with all this back and forth, wouldn't it be super wasteful to like download the same content repeatedly if nothing's changed?
Oh, you're absolutely right. That's where conditional requests come in.
Okay.
It's basically your browser saying, hey, if this page hasn't changed since I last saw it, don't bother sending me the whole thing again.
So like saving bandwidth, making browsing faster.
Exactly.
Okay.
So there's this header called IETF modified since.
All right.
It lets your browser, basically ask the server for an update only if the resource has been modified since a certain time.
Okay.
But remember that e-tag we talked about earlier?
Oh, yeah, that unique fingerprint for a resource.
Exactly. Yeah, it's like a digital signature for the content.
Right.
Well, there's this other header. It's called IETF none match.
Okay.
And it uses that e-tag to be even more precise. So if the e-tag hasn't changed, the server can just respond with a simple message.
Like, nope, nothing new here.
304, not modified yet.
Okay.
And your browser knows it can just use its cache copy.
That's amazing. All these little optimizations.
Yeah, every little bit helps.
It seems like every detail has been so carefully thought out to make the web, run as efficiently as possible.
Oh, absolutely. It's a constant evolution.
Now, let's shift gears a little bit. Let's talk about how these messages are actually structured. Like it's not just a jumble of text, right?
No, definitely not.
There must be some kind of organization to it, some logic.
Yeah, think of it like grammar, but for the web.
Grammar for the web. Okay.
So every HTTP message, whether it's a request from your browser or a response from the server, it's like a structured package.
Okay.
With different sections.
Okay.
First, you have the control data.
Okay.
This section, it contains things like the URI, the request method, and the HTTP version.
So this is telling the server, like, where to send the response and what the client wants it to do.
Exactly. And then you have the header section. This is where all those key value pairs we talked about go.
Like all those hidden instructions, content type, last modified, all that.
Exactly, yeah. Some of them are essential, for the basic communication.
Right.
Others provide more context, or they can even, like, change how the request works.
Interesting.
And then finally, you have the message body.
Okay.
And this is where the actual content lives.
So like the HTML for a web page, the image data, all of that.
Yeah, it's like the payload of the package.
The good stuff.
Exactly. No, sometimes you might even have a trailer section at the very end.
A trailer. What's that?
It's kind of like a postscript.
Okay.
And it contains, it can contain additional headers,
Hmm.
stuff that wasn't known until the message body was, like, fully processed.
A postscript for web request. Okay, what kind of information would go there?
Well, good question. It's often used for, like, digital signatures or checksums, things that are calculated after the message body is all put together. It helps ensure that the data wasn't corrupted during transmission.
Oh, so it's like a final scamp of authenticity.
Exactly. Now, with all these different versions of HTTP, the structure has changed over time, right?
That makes sense, yeah. It's like different versions of a programming language.
Yeah, it's kind of like that. The core concepts are kind of similar, but the specific keywords and the grammar might be a little different.
So different dialects of the same language, but they can all kind of understand each other to an extent.
Yeah, exactly, yeah. And just like with spoken language, clear communication really requires proper delineation.
Delineation.
And
Okay.
HTTP, that's called framing.
Framing. So how does the server know where one message ends and the next one begins?
Imagine like a continuous stream of data flowing between your browser and the server.
Okay. Yeah.
Framing is like putting each of those messages into its own separate envelope
Okay.
so they don't get all jumbled up.
So without framing, it'd be like trying to read a book where all the words were just mashed together with no spaces or punctuation.
Exactly.
Total chaos.
Different versions of HTTP might use different framing mechanisms,
Okay.
but the goal is always the same, right? Making sure communication is clear and unambiguous. Now, speaking of headers, remember when we were talking about content negotiation?
Oh, yeah, how my browser can tell the server what kind of content it prefers.
Right, and there are actually a bunch of other headers specifically for that,
Okay.
like accept.
All right.
That one lets you specify the media types you want, like HTML or plain text. Accept charset deals with character encodings. And accept encoding, that one lets you say, hey, I prefer content encodings like zip.
Zip, that's the one that shrinks the size of the data, right?
Exactly, so it transmits faster.
It's crazy how much detail goes into making sure I get like the best possible version of a web page.
It's all about the user experience. But how does the server actually know which of these headers to pay attention to, when it's making its decision?
Yeah, that's a good question.
That's where this header called vary comes in.
Okay.
Think of it like a note from the server saying, hey, when I picked this content for you, I considered these specific headers.
Oh, so it's like a transparency report for content negotiation.
Yeah, you could say that.
Okay.
It also it helps make sure that caches, those helpful middlemen we talked about, they store and serve the right version.
Right, because otherwise you might get a cached version that doesn't match what you ask for.
Exactly, yeah.
So it's like making sure you get your coffee with the right amount of sugar and milk.
Exactly.
Makes sense.
Now, that brings us to one of the most fundamental parts of HTTP, status codes.
Okay.
They're like the server's way of saying, hey, here's what happened with your request.
Okay, we all know about the infamous 404 not found error, but there's got to be a whole world of status codes beyond that, right?
Yeah, tons of them.
Let's unravel that mystery in the next part.
Sounds good?
Okay, so we've gone through like URIs and headers and all those hidden like conversations that happen when you browse the web.
It's a lot, right?
It's a lot. But now let's talk about those cryptic messages from the server.
Okay.
HTTP status codes.
Ah.
We all know the 404 not found error, but I'm guessing there's a whole lot more to it than that.
Oh, there's a whole world of status codes out there.
So it's not just like success or failures. There's like nuance to these messages, right?
Absolutely.
Okay, so let's start with the 200 level codes.
Okay.
Those usually mean things went okay, right?
Right. Generally indicates success, yeah.
So we got the familiar 200 okay,
Yeah.
but there's also 201 created,
That's right.
which is sent when like a request actually creates a new resource on the server.
Yep, successfully create something new.
So if I'm like submitting a form, that adds a new comment to a blog post or something,
Yeah.
I might get a 201 back. It's like the server saying, I got your message and I did the thing.
I did what you asked.
Okay, now what about 204, no content?
That was a little weird.
That sounds counterintuitive. Like, why would a server respond with nothing?
Right? It's a little strange, but it's actually super useful. It basically means like the server did what you ask,
Okay.
but there's no new data to send back.
Hmm.
This often happens with um, actions that just update existing data
Okay.
rather than fetching new stuff.
So, like clicking a mark as read button on an email.
Yeah.
The server might just send back a 204, like acknowledging that I did it,
Exactly.
without sending me back any actual content.
Silent confirmations.
It's like, yep, I did it. You're all set.
Exactly.
That makes a lot of sense. Now, what about those 300-level codes? I know they're about redirects, but I've always been kind of fuzzy on, like, the specifics.
Yeah, redirects, they're a big part of how we get around the web. So 301, move permanently. That was pretty self-explanatory.
Okay.
Tells the client that, the thing you're looking for, it's moved.
It's gone to a new home.
Yeah, to a new location permanently.
Permanently.
It's like a change of address notification
Okay.
for websites. And this is important not just for users, but also for search engines.
Right, so they can update their indexes.
Right, it lets them know that the old address, it's obsolete.
Right.
The new one's the one to use.
So we don't get a bunch of broken links.
Exactly, it helps keep the web organized.
Okay, now how is that different from 302 found?
Right, so 302 found that also means redirect.
Uh-huh.
But the difference is permanence.
Okay.
302 means it's temporary.
Temporary. Okay.
This is often used for things like load balancing,
Okay.
where the server might redirect you to a different server, like a less busy one, just to keep things running smoothly.
It's like, hey, this resource is temporarily unavailable here, but you can go over there for now.
Yeah, exactly.
Okay, are there any other redirect codes worth knowing?
Yeah, there's a less common one is 303C other.
303C other, okay.
This one has a more specific use. Like imagine you're submitting a form, using the post-test method.
Okay.
And the server, it processes the data, but instead of showing you the result directly, it might redirect you to a different page,
Okay.
like a confirmation message or something.
Okay.
That redirect would typically use a 303.
So it's like, I finished what you asked, but the relevant info is now over here.
Yeah, it's telling you where to look next.
Now let's talk about the 400-level codes.
Client errors.
Client errors. Those are the ones that usually mean, like, I messed something up, right?
Yeah, usually it's a problem with the request.
Okay.
So we talked about 401, unauthorized.
Right, that's like the server saying, hey, you need to log in.
You need to prove you are who you say you are.
Right, okay.
And then there's 403, forbidden.
Okay, what's that one?
So that means you are logged in, but you don't have permission to access whatever you're trying to get to.
So it's not about being the wrong person, it's about not having the right privileges.
Exactly.
Okay.
Like trying to sneak into a VIP area.
With the general admission ticket.
Yeah.
Okay. And then, of course, we have the infamous 404 not found.
Ah, yes. The classic.
Which, means the thing you're looking for, it just ain't there.
Page doesn't exist. Broken link.
The bane of every internet user's existence.
But even 404s, they can be helpful. A well-designed 404 page can, give you some suggestions.
Right. Or like try to guide you back to the homepage or something.
Exactly. Make a bad situation a little better.
Are there any other 400-level codes that are worth mentioning?
Yeah, there's one called 416, range not satisfiable.
Range not satisfiable. Okay.
This one's kind of specific. It's about these things called range requests,
Okay.
which let you request just part of a resource.
So like if I'm downloading a big file and my connection drops, I can use a range request to like pick up where I left off.
Yeah, exactly.
Okay.
But if the server can't do that, maybe you ask for a range that doesn't exist, then you'll get a 416.
Okay, it's like you're asking for a slice of cake that's not there.
Exactly.
Okay, now finally, let's talk about the 500-level codes.
The dreaded server errors.
Yeah, the ones that make web developers sweat.
Yeah, these usually mean something went wrong on the server side.
Like, it's not my fault.
Right.
It's the server's problem.
500 internal server error. That's the most general one.
So that basically means something's broken, but the server can't tell you exactly what.
Sorry, something's wrong, but I don't know what.
Okay.
And then you have 503 service unavailable.
Okay.
That means the server can't handle your request right now.
Maybe it's down for maintenance or something.
Yeah, could be where loaded, could be maintenance. It's temporary, though.
It's like out of order sign on a vending machine.
Right.
Frustrating, but hopefully temporary. I've noticed that some websites have like creative 500 error messages though.
Yeah, some people try to make it fun.
Which I appreciate.
A little humor can go a long way.
It can.
Sometimes the server might even include a retry after header with a 503
Okay.
to suggest when the client should try again.
Oh, that's nice of them. It's like, we're working on it. Come back later.
Exactly.
I have to say, I've really gained a new appreciation for these status codes. They
Yeah.
really are like their own language.
They are.
It's fascinating.
They tell you a lot about what's happening behind the scenes.
It's like having a secret decoder ring for the internet.
Yeah. It's pretty cool.
Knowing these codes, it demystifies web browsing, but it also, like, helps you understand how everything works together.
Yeah, it's all connected.
It's amazing how much we just take for granted when we're online, you know?
Right.
But knowing all this stuff about HTTP, URIs, headers, status codes, it makes the whole experience so much richer.
Absolutely. It's like, when you understand how something works, you appreciate it even more.
Exactly. Well, for our listeners who are now, like, super eager to learn even more,
Yeah.
I have one final thought for you to ponder.
Okay.
Look into the Content Security Policy header.
Ooh, good one.
This is a powerful tool. It helps protect websites from, like, all sorts of attacks.
Keeps things
And
secure.
it just goes to show how HTTP is constantly evolving
Always
to
changing.
make the web a safer place for everyone.
Very important.
Well, thank you so much for joining us on this deep dive into HTTP.
It's been fun.
Until next time, happy browsing, and may all your status codes be 200s.
200s all the way.